Hi, I'm Valeria Falzarano, a PhD student at the Italian Institute of Technology, and I'm going to present our study on exploiting robotics to assess the effect of fatigue on the human wrist. Fatigue is a temporary decline in muscle performance associated with intense muscle use. Sustained contraction produces high quantitative lactate, whose presence led to extra and intracellular pH changes. The number of catabolites produced by muscle fiber during muscle activity is proportional to the decrease in the mean frequency of surface electromyographic signals. Therefore, this decrease becomes an indicator of muscle fatigue. The main idea of this work was to exploit robotics to investigate the effect of fatigue on the human wrist joint by computing the change in sensory motor perception, mechanical properties, and motor skills through robotic assessment protocols able to measure the position sense and the stiffness of the wrist and the maximum isometric wrist forces. The robotic device used in this study is the wristbot, an haptic manipulandum which allows assisted or active movements along the 3 degrees of freedom of the wrist. It is equipped with a virtual reality environment that provides visual feedback to the user, and its robotic handle is wrapped with a soft sensor able to measure the exerted grip force during the task. The experimental protocol consists of 2 sessions in 2 different days. During each session, the subject's right forearm was fixed to the robot and equipped with bipolar electrode both on flexor and extensor muscles. Both sessions were entirely performed using the robotic device and included a pre-fatigue assessment, a fatigue task, and 4 post-fatigue assessments. First subject performed a warm-up session consisting of a 2-minute tracking task with low-level resistive forces. Then, during each force assessment, subjects exerted their maximum grip force and performed their maximum voluntary isometric wrist contraction in flexion and extension directions. The position sense was tested with an active paradigm. First, target positions were haptically identified by moving towards a virtual wall placed along the flexion direction. Then, from the neutral position, subject had to replicate the previously assumed joint configurations. Wrist stiffness was assessed through the delivery of position control disturbances in wrist flexion extension direction and computed through a mechanical impedance model of the wrist joint. These external perturbations were characterized by small amplitude and fast velocity, causing rotation at the wrist joint from the neutral position. During the fatigue task, subject performed continuous reaching movement from the neutral position towards flexion direction. A resistive torque opposed subject movement toward flexion and facilitated those towards extension. Real-time analysis of EMG signals enabled the implementation of a real-time algorithm capable of detecting fatigue and terminating the task automatically. This is a representative plot showing how the mean frequency value of the flexor muscles in red and green dropped immediately after the fatigue task to then recover to the pre-fatigue values at the end of the protocol, differently from those of extensor muscle that was not involved in the fatigue task. Next, we demonstrated that sensory motor and mechanical properties of the wrist joint were affected by the fatigue state. As shown in the figures, both parameters decreased significantly after the fatigue task, showing a tendency to drop until 5 minutes after the task and then slightly recovering. To conclude, by exploiting the high temporal and spatial resolution of robotic devices, it is possible to have accurate measurement, control exactly the timing, and constantly monitor real-time changes and safety conditions. Moreover, a robotic device ensures a repeatable and controlled experimental condition and the ability to interface with other external devices. These advantages of using robotics allowed us to implement a robust and repeatable task that detected fatigue state based on physiological changes in muscle activity and able to identify which feature may be affected in the fatigue process. Thank you for the attention.